Okay, good morning to all, and we are covering this unit number 2, orthographic projection. So far, we have covered the as elephant as an object, how a normal person or normal people draw the view of a elephant, single view of a elephant, and how engineer draw the single views of the elephant, that is front view, top view, side view, and left hand side view. Also, we have covered the principal planes and auxiliary planes. Principal planes are the horizontal plane, so this is the horizontal plane and vertical plane. Horizontal plane parallel to the ground, vertical plane perpendicular to the ground and perpendicular to the horizontal plane. Auxiliary planes are on basis of inclination to the horizontal plane and vertical plane, they are auxiliary vertical plane, so it is inclined to the vertical plane. Auxiliary inclined plane, it is inclined to the horizontal plane and perpendicular to the vertical plane, and profile planes are perpendicular to the both the planes, vertical plane as well as horizontal plane. Quadrant system we have covered in the last lecture. So quadrant system, because of the interaction of these two planes, principal planes, horizontal plane and vertical plane. So x-axis as a horizontal plane, y-axis as a vertical plane, and the interaction line between this horizontal plane and vertical plane is xy line. And what is meaning of the object in first quadrant, second quadrant, third quadrant, and fourth quadrant? So quick review about that. So first quadrant means above HP in front of the VP. Second quadrant means above HP behind the VP. Third quadrant means below the HP behind the VP. And fourth quadrant means below the HP in front of the VP. Once again, so observer, so we get the front view of the first quadrant, top view of the first quadrant, top view on the horizontal plane, front view on the vertical plane. So this is the position of a object in first quadrant. Object in first quadrant, above the HP in front of the VP. Object in second quadrant means, so this is the object in second quadrant, above the HP behind the VP. Object in third quadrant, that is below the HP behind the VP, below the HP behind the VP. And object in fourth quadrant, below the HP in front of the VP, below the HP in front of the VP. If we are looking this interaction of the reference planes, we get x-axis and y-axis. So first quadrant, second quadrant with respect to the horizontal plane, we can see here first quadrant, second quadrant, third quadrant, and fourth quadrant. First quadrant, above the HP in front of the VP, above the HP behind the VP, second quadrant, below the HP behind the VP, third quadrant, below the HP in front of the VP, fourth quadrant. So combination of a observer, object, and plane. If the object is in first quadrant or fourth quadrant, we have combination as observer, object, plane. For the front view, observer, object, and plane. Observer, object, and plane. If the object is in second quadrant and third quadrant, we have a combination like observer, plane, and object. So observer, so this is the observer, this is the vertical plane, and here object. Observer, plane, object. Okay, glass box concept for the object in the third quadrant, you can see. So this is the transparent plane, horizontal plane, transparent vertical plane of the glass box. Horizontal plane, vertical plane. So object is inside the box. So that is the object in third quadrant, and we are looking that object through the plane, transparent plane. So this plane, horizontal surface, this horizontal surface is the horizontal surface is horizontal plane behind the vertical plane, and this one is the vertical plane or vertical surface below the horizontal plane. So object inside the box is below the horizontal plane, behind the vertical plane, and we are looking that object like here observer, this is the plane and this is the object, observer, plane, object. observer, plane, object. So you get the projection of the front view below the xy line, and here projection of the object for the top view on the horizontal plane after rotation, that is clockwise rotation of the horizontal plane. We get the position of a or views of the object in the third quadrant, the top view above the xy line, top view above the xy line, so this is the xy line, and front view below the xy line, front view below the xy line, this is the xy line, interaction of the two planes, this line. Okay, I will change the color so it is easy to understand. Blue color I will. Okay, so this line is the interaction line of the two planes, that is horizontal plane and vertical plane. So horizontal plane x-axis, vertical plane y-axis, so this line is the xy line. So, and we are getting the projection of this object, circular object, on this vertical plane. So here we get the from the front, if we are looking towards the object from the front, we get the projections on this vertical plane. So this front view is below the xy line, the front view below the xy line, you can see here. And we get the top view, the projections, if we are looking towards the object from the top through this plane, we get the projections on this horizontal plane. So this one is the front, sorry, this one is the top view. So top view after rotation of the horizontal plane in clockwise direction, so this part will come above the xy line. So top view above the xy line, and we are talking about the third quadrant. We are talking about the third quadrant. Okay. Okay. So we'll see exact position of the front view, top view, and left hand side view for the first angle projection, that is object is in first quadrant, and third angle projection, that is object in the third quadrant. So this is the object, and we are looking for the front view, top view, and side view. Now the observer is at this place, this side is the, if observer is looking from this side is the left hand side of the observer, this side is the left hand side of the observer, and this back side is the right hand side of the observer. This one is the right hand side of the observer, and this side is the left hand side of the observer. It means that if you are looking from this side, so this side view is the left hand side view, and if you are looking from this side, as this one is the right hand side of our observer, so it becomes the right hand side view. So where we get these side views, so we get these side views on the respective planes. So we'll see the position of the planes on which we are getting this left hand side view and right hand side view. Okay. So for side view means this is for the left hand side view. For front view, the object is in front of the observer and observer is looking from the top, so we get top view on the HP. We will get top view on the HP. Okay. So for the front view first, the front view will obtain on the horizontal plane. Vertical plane. Front view will obtain on the vertical plane. Vertical plane in front of us, and observer, object, and vertical plane. We will get the projections on the vertical plane. So this is the projections for the front view. We are looking from the top, these are the projections, and we are getting the top view on the horizontal plane, and the side view on the profile plane. So profile plane, you can see here, perpendicular to the vertical plane as well as the horizontal plane. Profile plane, this profile plane is on right side, so RPP, right profile plane. So this profile plane is RPP. Right profile plane. On this right profile plane, we are looking from the left side of the observer. So this view is the left hand side view. So this view is the left hand side view. Front view, top view, and left hand side view. And we can see here, with respect to the XY line, the position of these views. So front view, top view below the xy line, front view above the xy line, and side view beside the front view. And on which side? So it is on the right side, left hand side view, on the right side of the front view, left hand side view. So this left hand side view is on the right of the front view. This left hand side view on the right of the front view. This is the front view, and the left hand side view is the on the right of the front view. So this side view is left hand side view is on the right side of the front view. If you are drawing the right hand side view, we get on this side, right hand side view on this side. So right hand side view on this side, so we get here right hand side view, right hand side view on the left of the front view in the first angle method of projection. For the same object, if you are considering the same object is placed inside the third quadrant. Third quadrant means below horizontal plane and behind the vertical plane, below the horizontal plane and behind the vertical plane. So this is the horizontal plane, and now you can see object is below the horizontal plane. This object is below the horizontal plane, and combination is like for the observer, object and plane. You can see you are looking from the top. So this is the observer, this is the plane, and this is the object. So combination is like observer, plane and object. So we get the projections on the horizontal plane. We get the projections here on the horizontal plane. So you get the projections of a top view on the horizontal plane, projections of the top view on the horizontal plane. So these are the projections. This is the top view. You are looking from the top. Okay. So object is behind the vertical plane. So this is the vertical plane and the object is behind the vertical plane, like that glass box concept. So this is the behind the vertical plane. So we get the projections for the front view on the vertical plane, projections for the front view on the vertical plane. So this is the front view of the object. So you can see this is our xy line. You can see this one is our xy line. This line is the xy line. Now clearly you can see here the front view is below the xy line. Front view is the below the xy line. Front view is the below the xy line. You can see here also. This is the xy line. This is the xy line, and front view is below the xy line. Front view is below the xy line. Okay, and as HP horizontal plane rotate in clockwise direction, HP is rotating in clockwise direction. So we get top view above the xy line. Top view this will rotate above the xy line. So top view also will rotate here. So this is the above the xy line. So top view here you can see top view above the xy line. And left hand side view or right hand side view, side views are beside the front view. And which one is the plane? So this is the LPP, left profile plane. So observer, plane and object, you get projections on the LPP. So left hand side view for third quadrant on the left of the front view, left hand side view on the left side of the front view, left hand side view on the left of the front view. In first angle method of projection we get condition like that. For the first quadrant or first angle method of projection, xy line, so you are getting here front view, top view below the xy line, and beside the front view we are getting the left hand side view, but on the right side of the front view, left hand side view on the right side of the front view. Here you can see here left hand side view on the left of the front view. So that is the difference between the first angle method of projection and third angle method of projection. Front view in first quadrant above the xy line, front view in the third quadrant below the xy line, top view in the first quadrant below the xy line, top view in the third quadrant above the xy line, and left hand side view on the left side of the front view for the third quadrant, left hand side view on the right side of the front view in the first quadrant. Okay. So how to convert that pictorial view, three-dimensional view, into orthographic view, we will see in this. Okay, 1 minute. We will see how to convert pictorial view how to convert the pictorial view. So this is the pictorial view, that is three-dimensional view, or you can say isometric view. So three-dimensional view, and the arrow is given the direction of a observer. So observer is looking from this direction. This is the direction of a observer. So you can see this is the three-dimensional view. You can see this one is the length of the object. This is the length of the object. And so you are looking from the front. So this is the length of the object. It has some height. Object has some height. So which is the length? Okay. This is the length of the object. This is the length of the object. Three-dimensional view, length of the object. So you can see here from in this direction, you can see this is the width of the object. So from this point to this point, from here to here, this is the width of the object. From this point in this line, or in this direction, you can say this is the height of the object. 1 minute. Okay, this is the height of the object. So in this pictorial view, we have three dimensions: length into width into height, and we have to convert this figure into orthographic views. Orthographic views means front view, top view, and side view. Now the observer position is this one. So this is the position of the observer. So this is the length L. So if we are looking towards any object from the front side, and we have to convert that object into two-dimensional, so we have two dimensions only, that is the length of the object and height of the object. Length of the object and height of the object. Length of the object and height of the object. If we are looking towards any object from the top, so width of the object and length of the object come into the picture. So height of the object will not come into the picture. Only two dimensions for the top view. Which one? For top view, length of the object and width of the object. Length of the object and width of the object. And if you are drawing the side view of any object, so side view is this one. So this side view means right hand side view. So this side view is the right hand side view. This is the observer. So this one is the right hand of the observer. This side is the left hand side of the observer. So if your observer is looking from this side, so this is the right hand side view, and we get we required for the right hand side view the width of the object. For right hand side view, what we require, width of the object and height of the object. Width of the object and height of the object. Okay, we'll see the steps one by one. So the first step is study the object. So study the object means study where the dimensions are exactly given. So we'll see where the dimensions are given. So you can see here the 86 dimension is given here. 86 dimension is given from which point? So you can see from the locus of this point, up to here. So this is the maximum length you can see here. From this point, up to this point. So maximum length is given 86. So again here some dimension is given 26. So this dimension is the 26 from this point to this point. Also you can see here another dimension width direction is given 22 mm. So here dimension is given as a 22 up to this point. So this point is the center point for this arc. So center point is arc of a radius r 26. So 26 mm arc. So for that 26 mm arc, for this 26 mm arc, this one is the center point, and you can see here from the center point up to the last point, end point, or in width direction 22 mm the dimension is given. So maximum dimension in width direction you cannot take as a 26. Okay, why? Because the arc direction, so that is center point to here, is 26 mm already given. This arc dimension is the 26 mm, and from this point 22 mm up the distance from the last end up to from this end 22 mm. So 22 plus 26, the dimension of the width is 48 mm. Dimension of the width here, w, 1 minute, w is 48 mm. So maximum length from this point to this point, L is given 86 mm. So L is equal to 86 mm. W is equal to 48 mm. You can see the height dimensions. So 9 mm height is given for this surface. From the bottom to this surface 9 mm height is given, and from this surface you can see here the same line. So from this surface up to the center point, this center point, 22 mm height is given. So 9 plus 22 mm height, 9 plus 22 mm. So from this center point, again here is the one semicircle arc, semicircular arc. From this center point there are two arcs, one the circular part of diameter 17 mm, and another is the semicircular part of the radius 17 mm. So this radius 17 mm, this radius 17 mm is for this semicircle, and diameter 17 mm is for this circle. So maximum height we get from this, for this drawing, is 17 mm from the center to the arc length, from the center point to this semicircle part here, from center point to this bottom 22 mm height, and from this surface, horizontal surface, to the ground 9 mm. So height total is 22 plus 9, 31 plus 17. किती झाले? 48, 48. Okay, 17 plus 22 plus 9, so it's 48. So height 48, length 86, and width 48. Okay, width 48, 86, 48. So second stage is find the overall size of the object, that is length, width, height, that is 48, 86, 48. Draw the blocks for front view, that is length into height, top view length into width, and side view width into height in their respective position according to the method of projection. So considering the first angle method of projection, we will draw first the location of the front view, top view, and side view with respect to the first angle method of projection. Now we are considering first angle method of projection. So where is the location for this, or where is the position of this front view? So first angle method of projection, front view is the above the xy line, front view above the xy line. And for the front view, for drawing that rectangular block, we require the length into height. So what is the length? 86. So this rectangle box is of a dimension, so this is the 86, and the height dimension is the 48 by 86. So below the front view we have to draw top view. So on the projections of a front view, we got the top view with the length 86 and width 48. So this is the length 86, the same as the front view. On the projections of the front view, 86 again here, and width 48, and we are getting here right hand side view. So right hand side view on the left side of the front view. So on the left side of a front view, we have to draw the right hand side view. So here we get right hand side view, right hand side view. So this right hand side view of a dimensions 48 by 48. So on the 45-degree line, if you draw the projections of the top view and from the front view, so those projections will intersect on these corners and we directly get the rectangle for the right hand side view. So okay, I will repeat the same thing for better understanding on the separate sheet. Okay, so we'll take another screen, that is white screen, and on this screen I will draw the positions of the front view, top view and side view. We know the length, height and width. Okay, so what is the length? Length is 86, height is equal to 48, and width is equal to 48. Okay, so draw the xy line. So this is the xy line. Okay, so front view in the first angle method of projection is above the xy line. Front view above the xy line. So I am drawing the front view above the xy line here. This is the front view. What is the dimension for rectangle? So length and height. 86 and here 48. So on the projections of the front view, we get length of the top view. So this is the length of the top view, 86. This is the top view, and this dimension is the width, that is 48. So width is equal to 48, and we have to draw right hand side here. So the projections of the top view and we have to draw the projections of the front view. So projections of the front view and top view intersect at these points. This is the point, this point and this point. So here we directly get the rectangle for the right hand side view, that is size of 48 by 48. So this is the 48 mm width, so it is directly converted into 48 mm right hand side view, 48 mm height into 48 mm. So width into height, this side of the top view. Here we directly get the projected for the right hand side view. Okay, front view, top view, right hand side view. So this method is with the first angle method of projection. First angle. What happens in third angle? So we'll draw the same thing for the third angle. Draw the xy line. So front view is below the xy line. Front view is below the xy line. So draw the front view. This is the rectangle for the front view in the third angle method of projection. So front view again same size, length into height, 86 by 48. So projections of the front view, we will get top view. So here we will get the top view. The top view again is 86 and this is the 48, and we have to project those front view and top view to get the right hand side view. So right hand side view in third angle method of projection will be beside the right side of the front view. So on this 45-degree line we have to project the projection of the top view and the projections of the front view. So this rectangle or the square gives us the reference block for this right hand side. This reference block of size 48 mm by 48 mm. Top view, front view and right hand side view. First angle method of projection, front view, top view, right hand side view. First angle method of projection, this is the xy line and this one is the x1 y1 line. So this is the xy line and this line is the x1 y1 line. Same, this line is the x1 y1 line. Okay, so after drawing those blocks for the front view, top view and side view, the next thing is take suitable distance up above the blocks from reference lines like xy line and x1 y1 line. So keep the same distance of the blocks from the xy line and x1 y1 line. Draw the first view which gives maximum visibility and which is simple to draw. So which one is the simple to draw here? So simple to draw is the circular part or arc part is simple to draw. So we can see in the front view we have two circular parts. Means one circle is there, whole dimension r with dimension is 517, 17 mm diameter circle, whole diameter, and you can see another semicircular part, that is r17. So after locating the center point of that particular circular part or semicircular part, we can easily draw that circle and semicircle with the help of a compass. So I have to locate the position of that center point with respect to the height and with respect to the length. So from left side, you can see here, from left side the circular part is at what distance? So this distance. So from the left side, so this is the left side of this one is the observer position. So this is the left side and this one is the right side, and from the left side we can see if this is the semicircle arc means this one is the diameter part. This is the diameter part for the semicircle. This one is the diameter part passing through the center. So center point on the left side 17 mm, on the right side 17 mm. So center point from the left side is the 17 mm. So if this is the block, rectangular block, length by height for the front view, so we can draw a line or locus of a line at 17 mm from the left side. So on this locus there is the center line. So this is the vertical line 17 mm at from the left side, and from the top we can say that same 17 mm from the top. So 17 mm from the top. Why? Because this is the center point and this is the semicircular part. So R17 is given. So 17 mm distance between this top point to this center point. 17 mm is distance. So again this line is parallel to this horizontal line 17 mm apart. So we get the center point, and with the center point and the radius equal to 17 mm, we can easily draw the semicircle here, and also with the help of radius 8.5 mm in the compass we can easily draw here the circle part here. So this part, okay. And in the top view also we can locate this center point R26 mm from the left and 26 mm from the downside. So in top view we get the center point. So we can easily draw this quarter arc 1/4 arc with the radius 26 mm. Quarter arc with the radius 26 mm. Okay. In respective block, first draw the contour of the view followed by the visible edge at the end, draw the hidden details. So visible edge in the front view, which are the visible edge? So front view, this one is the visible edge, this one is the visible edge, you can directly see from the front side. So here we get like vertical lines, that is visible edge, vertical line as a visible edge, this line visible edge, this is the visible edge, this one is also visible edge. So it will look like something like this. These are the visible edge. So this edge is also visible edge, this edge. So this is like the front view for this particular object. Okay. After drawing all the views, give all necessary dimensions and specify the major dimensions. So dimensions given in the drawing, we have to mention all those dimensions, that is 26 mm, 86 mm. So here we have to give the dimension for the circular part, that is or whole part 517, this circular or arc part R17, this circular or arc part R26. So this dimension, center line dimensions from this in width direction, that is 22 mm, height of this surface 9 mm, height of this center point from this location 22 mm. So all dimensions we have to mention in this views. Okay. So important points. So how exactly draw the line part? Okay. If line is parallel to both the vertical plane and horizontal plane, then front view and top view of the line always give us true length or respectively. If this is the line, if you are looking towards the object and we can see that that line is parallel to the vertical plane, so we have to draw the same line length on the vertical plane. So projections of the line like this, true length, or in the top view you can see we get the true length. Now this line is parallel to the vertical plane, perpendicular to the horizontal plane, parallel to the vertical plane and perpendicular to the horizontal plane. So you get the point in the horizontal plane, that is top view in the horizontal plane and true length in the vertical plane. If the line is perpendicular to one of the reference plane, that is here line is perpendicular to the horizontal plane, then the view is obtained is always point view. View is the point view. And now with respect to the planes, if the plane is parallel to the vertical plane, plane is parallel to the vertical plane, we get here the true shape of the plane. This is the vertical plane parallel to the vertical plane. Sorry, this is the vertical surface and which is parallel to the vertical plane, so we get here true shape. So this surface, you can see here, this surface is parallel to the horizontal plane, this surface is parallel to the horizontal plane, horizontal surface we can say, and we get here the true shape. So going back to our drawing, so which surface is here? Horizontal surface parallel to the horizontal plane. So you can say this surface is parallel to the horizontal plane, this surface, this is the horizontal surface. So we get the true shape in the top view. How? We get like this, like this. So this is the true shape for this surface, and this surface, I am changing the ink, 1 minute. Okay, so this surface is a parallel to the vertical plane. This is the front, you are looking from this side, so this is the parallel to the vertical plane. In vertical plane you are getting the true shape for this surface like this. You will get the true shape for this surface. So this surface is parallel to the vertical plane. This surface, you can say this point, particular this point, okay, this point is 48 mm from the back side, okay, 48 mm from the back side, and this point is 26 mm from the back side. So this is the back side, and from this back side this point is 48 mm, this distance is the 48 mm, this distance is the 26 mm. So this surface is not the parallel to the vertical plane, this surface is not a parallel to the vertical plane. So we got auxiliary view, or we can say for the front view it's a elevated view of this surface, elevated view of the surface, not a true shape, not a true shape for this surface. Okay, we get the rectangular view but not a true shape of the surface. Okay, so this length is different. The actual length of this rectangular is different, and we are getting only projected view of that surface, which is not the true shape or actual size of the shape. So for this surface we get the true shapes, and the dimensions are equal to the true shape dimensions, and projected views dimensions are equal. So for this projected view dimensions are different than the true shape, and they are less than the true shape. Okay, we'll see one example, simple example, this one, front view, top view and side view. Okay, so you are looking from the front, so this is the front view. You are looking from this front, this is the front view. This is front view you are obtaining on the vertical plane with the first angle method of projection. The front view is above the xy line, so this is the xy line, front view is above the xy line, and these two surfaces, these two blue surfaces are the parallel to the vertical plane. These surfaces are the parallel to the vertical plane, so you directly get the true shape here. So rectangular size same here, another rectangle same size here, so two rectangles here in the front view. Similarly, this green surface is parallel to the horizontal plane. The projections of the top view we are getting on the horizontal plane. So again, these two surfaces we get the true shapes, top view, and left hand side view. You can say this surface, this L-shaped surface is parallel to the RPP, parallel to the RPP, right profile plane. On the right profile plane we are getting the left hand side view, as this is the position of the observer, this is the left side of the observer, this is the right side of the observer, and we are looking from the left side of the observer, that is we are getting left hand side view on the right profile plane, or right side of the front view, Okay, we'll stop here and we'll see some examples in the next lecture. So examples with the, so I will show you one example. Okay, this type of examples in the next lecture. Thank you.